Hi, I'm Tom Stephenson, and welcome to Construction Project Management. I'm a professor of construction management, and if you're new to the channel, on this channel we try to have videos that really sort of get at the core of running construction projects. All areas of construction and construction management are covered. If you're interested in particular areas, check my playlist. You'll see I have whole courses of material put up there on the playlist. Today we're continuing our discussions on the 8 areas of waste in construction. Really, this is part of lean philosophies, lean construction philosophies, pulled from construction and the manufacturing sectors. And today we're going to be looking at transportation. So we're continuing our discussion, and let's go forward here. So the 8 areas of waste, defects, we've looked at that in a previous video. I'll have them in the directions below. You could also check the playlists under project management tips. Defects, overproduction, waiting, non-utilized talent. That was a really interesting one, the last video that we looked at. And today we're going to be looking at transportation of goods. Now the easy way to remember the 8 areas of waste is that they spell the word downtime, right? Very easy to remember because in construction, we get too climatized about the way things are and we don't really notice things after a while. Well, with lean construction, we're going to be very observant, we're going to be alert, and we're going to be wanting to continuously improve. But to do that, we really have to have a good understanding of what's not working so well. What could we improve on? Where's the low-hanging fruits of what we can do better? And so today we're looking at transportation, which I also include to mean the supply chain, and we'll unpack that a little bit here. So what does transportation encompass and how do I define it? You know, I pull in a few other different aspects. We're coming off COVID a few years back, right? And it caused quite a lot of upheaval in the supply chains, and you know, there's still upheavals in the supply chains. I'll talk a little bit about that, how our supply chains are really a fragile but amazing things, really amazing things. But really, we're thinking about getting things made and delivered when we need it. That's transportation. And transportation is one of those 8 areas of waste, like a lot of them really, that they're not mutually exclusive. When you got one thing going on in one of the areas of waste, you might have another thing that's related to it that's in another 2 or 3 areas of the areas of waste. Very easy to have happen. Sort of one thing ripples into another thing. It's almost like schedules and delays, how one delay causes a whole bunch of ripple effects throughout the project. All right, so transportation waste involves unnecessary movement of materials, equipment, or workers between locations on a construction site or between different construction sites. Like transportation waste is when we have to move things multiple times. It's also when we don't get things when we want them or when we need them or where we need them. And so we get it too early, we get it too late, we get too much of it. I'll get more into the other area, which we'll talk about next time, inventory and inventory controls. And so this obviously can really ripple, as I said, into delays and scheduled delays. And really, I've said this in a number of other videos. You have to think that there's a per diem cost to running your project every day. You've got trailers on site, you've got an admin team on site, and all of these costs, they keep getting extended and extended out longer and longer. If you have basically traffic flow people and you're helping with assisting with deliveries, the longer the project goes, the longer they have to be there. You know, there's all these extra costs that come into play when you don't get the supply chain and transportation done right. And that brings me to my topic, or my thought on this when I was researching this a while back, is this article. And it was actually, you can read the whole article online. I've got the link there, or you can at least, you know, all you have to do is Google iPencil by Leonard E. Reed and it'll come up right away. Like that's probably the fastest way to get it. And I remember when I heard it, I don't know if it was Tim Ferriss' podcast or one of the podcasts, and they mentioned iPencil and supply chains. And so my first thought when I heard, of course, iPencil and supply chains was I was thinking, oh yeah, iPencil, right? Oh yeah, supply chain issues. I could imagine. Just think about, because when I think about a supply chain, I think about, well, what goes into making something like this? Like, what goes into making something like this? Of course, I was wrong. I looked up the article, and it wasn't talking about iPencil, because this article was written in the 1950s. Okay, it's a very renowned article, and it gets discussed a lot. It was talking about a pencil, I meaning I the pencil, and it's this nifty little article that's written. I'll read it from my iPad, a little bit of it, because it's got a lot of stuff that's here, and it really talks about what goes into making a pencil. And you're going to be able to extrapolate this when you start thinking about construction in a really big way, right? And so it says, my family tree begins with what in fact is a tree, a cedar of straight grain that grows in Northern California and Oregon. Now contemplate all the saws, trucks, rope, and countless other gear used in harvesting and carting the cedar logs to the railway siding. Think of all the persons and numberless skills that went into their fabrication, the mining of ore, the making of steel, in the refinement to make saws, axes, motors, the growing of hemp, bringing it through all the stages to heavy strong rope, the logging camps with their beds, the mess halls, the cookery, and the raising of all the foods. Why, untold thousands of people had a hand in every cup of coffee the loggers drink at the site. The logs are shipped to a mill. Can you imagine the individuals who make flat cars and rails, the railway engines, who construct and install the communication systems incidental thereto? These legions are among my antecedents. Consider the millwork. The cedar logs are cut into small pencil-length slats and then cut into a quarter-inch slices. They are kiln dried. They're tinted for the same reason. People prefer that I look. The kiln are drying, and the slats are waxed and kiln dried again. How many skills went into making the tint and the kilns, into supplying the heat, the light, the power, the belts, the motors, and it goes on and on and on about this, right? In the factory, and the $4 million of machinery that's in the factory building to put the pencils together. The lead, the making of the graphite, which is basically, there is no lead in pencils, right? It's graphite. And the mining of the graphite, and goes on and on and on. The bit of metal furl. All right, now you're getting into the steel of this, but you got into the steel with the saws, with the trucks and the trains and the equipment to move the pencils. When you go through this whole article, you start to think, how do we ever get this, that we can go into a store and buy it for like pennies on a dollar, right? Like, this is amazing what we are able to accomplish with a supply chain. Well, now think about construction. Think about all the things that go into building a building. Concrete, we've got to basically make Portland cement. That's no small task, right? Steel, we've got to make the steel for basically, we've got to mine the steel. All of the steps and the processes that are involved. So this, it's not surprising that we often don't get things exactly when we want them. That shouldn't be too surprising, because the level of complexity in our supply chains is so high. The other thing is, no one person, the article talks about this, no one person knows how to make the pencil from start to finish, like actually make it, not conceptually or theoretically understand how it's made, but actually make it from scratch, right? That's a lot of work. And so now we're talking about this. We're not, you want to get into another level of sophistication, talk about an iPencil, talk about an iPad, talk about the equipment that we use today with basically scanning materials and BIM technologies and those types of things. So our equipment that goes into our buildings, our heating systems, our plumbing systems, and go on and on and on. it is a high level of complexity. And so we have to think about transportation, which is backed up by having something made and is part of the infrastructure of everything that we get done. That's part of our supply chain. And so that means, of course, it's going to overlap with other areas of waste too. When things aren't quite done the way that you wanted. Sometimes you're going to get more of something that you wanted than you wanted. Wait time, very often, that may mean that one little step in that supply chain can have that ripple effect that it slows down your ability to actually construct the building that you're after. And I know, Toyota is sort of the poster child for basically lean manufacturing and just in time, getting things just when you need them. But they're smart enough to know that there's certain things they got to have some buffers in. They've got to have some, and we'll talk about that the next session, inventory in, or else they won't have exactly what they want when they need it. But they do work the system very close, because getting transportation done right will really, really accelerate your ability to deliver your projects on time. And so what are some of the things that we think about? What are some of the common causes of transportation waste? Well, and these common causes of transportation waste, we can, for the most part, flip them around. What are some of the strengths of running a really good, efficient supply chain transportation? Poor site layout and planning. Well, getting things where we want them, when we want them, right? And so that they're not in the way of other things. That's important. So we have to think about how to effectively lay out our floor space, our sites, as effectively and efficiently as possible. How things will flow through our project is very important to think about that. How materials will move from one space to the next to being in their space. Of course, tied to that is inadequate inventory management. So getting the things delivered when we want them, when we need them, is very important, so that we don't have workers waiting for work and we don't have too much stuff there delivered ahead of time. And sometimes a lot of it is not building strong communication. A lot of it is not pre-planning, being proactive in the early parts of the construction process, and especially when we're contracting with vendors and we're contracting with trades, to make sure that they're aware of some of our issues with regards to deliveries, and making sure that that doesn't cause any unnecessary bottlenecks. So I have this example of millwork in a hospital. Just imagine you're doing this large hospital. Let's say, pick a number. Let's say there's $20,000 liquidated damages per day that you don't finish it. That's probably a low number for a big hospital. But let's just pick $20,000 a day. That for every day you're late, it's $20,000 liquidated damages. All right. So you've got when does the millwork come? It comes near the end of a project. And I heard this as an example, a case study. And so millwork comes near the end of the project. Well, one of the things that as a project manager in construction, you should be very nervous about stuff near the end being delayed. You could be on track the whole project and something doesn't happen near the end. You don't get a gold star for being on time 90% of the project. The client only remembers what's at the end. Liquidated damages are going to happen at the end when you don't fulfill that. So you are near the end of the project. You're installing the millwork. You have the people there to install it, but you have basically your millwork supplier is in another city. So I'm in Toronto, Canada. Let's say it's in Winnipeg. And Winnipeg is a fairly far drive from Toronto. I'd have to look it up. But let's just say for argument's sake that it's about a 24-hour drive. All right. So if it's a 24-hour drive, it might not be quite that long, but 24-hour drive, you're the supplier, right? So you're filling up your transport truck. You don't want to send that transport truck half full. or a quarter full. You want to send it completely filled because you're sending a driver and it's going to take all that time. It's going to take all that fuel. So you're trying to optimize for your costs. So it's going to take you, let's say, 2 weeks to fill up that truck with all the millwork. Meanwhile, at the hospital, you've got installers there that could be installing that. And so this is starting to delay you on your project. Now, the millwork manufacturer maybe already has half the truck filled, right? But they're waiting on the other half to be made. And that's going to take an extra 2 weeks. Well, if you have $20,000 liquidated damages and it's based on calendar days, that would be, let's see, $280,000 in liquidated damages. Now, the millwork manufacturer doesn't want to send half a load because you've got the extra cost of the delivery truck. So let's say the delivery truck is $5,000, right? To gas it, fuel it, send the driver there and send it back, empty, likely. Well, that's $6,000 compared to 14 days of liquidated damages. What makes more sense, right? Like, it makes more sense to send that truck half filled. That's where I'm saying miscommunication, lack of coordination between teams, procurement processes that, didn't really discuss having smaller batches, improve flow, right? Smaller batches will make amazing differences in your schedule when you can do that, when you can have ideally, technically, theoretically, one-piece flow. But let's just think big batch is a full truck, maybe a quarter truck or a half a truck, that would be a smaller batch comparatively. And thinking in those terms could have dramatic savings. So that would be total transportation waste. Like that's where that ball dropped between basically each party not fully comprehending things. And so we have to look at then our communication systems and how we're collaborating on our projects. We can also think, so just in time, that's your one piece flow. It's coming off the truck, it's being installed. It's like one piece flow, just happening very, very quickly. That's ideal. In construction, like just in time, even in manufacturing, is not exactly just in time. There's always buffers, all right? There's schedule buffers, there's inventory buffers, there's capacity buffers. That gives us a little bit of adjustment, right? But we do want to, in construction, get as close as possible. So that's what we call last responsible moment. That's with what's reasonable with our understanding of the limitations of our vendors, our trades, and working with that to try to get it as close as possible to just in time. That might mean if it's a new supplier and we don't trust them fully, we want to get this thing a week ahead of time or 3 days ahead of time. If we're working with a very trusted vendor, reliable, we might be okay with the day of or the day before, right? So looking at that and trying to constantly work that to get it closer and closer. And that's pulling instead of pushing. Pushing is, I've got all this equipment. You ordered it, we're delivering it, right? And that's just getting pushed onto your site, but you're not ready for it yet. That's no good, right? So transportation is all about getting things pulled to the site as you need them, not pushed to the site when you don't need it, right? And so we also have to think about large projects. Like I've been working with a number of clients as of late that have been, they take care of, $10 billion projects, okay? Very, very large projects. And when you start getting into that kind of scope and scale, you really have to work very closely with your vendors, suppliers, and really sort of lay these things out, because that'll be your bottleneck, getting something of the magnitude that you need made in that time frame. And it's not just on one vendor or trade, it's on a multiple of vendors and trades, and trying to get that in alignment ahead of the project, right? That is challenging. But that is what you're trying to do with transportation. That's what you're trying to do with supply chain management from that perspective. Now, on a smaller, because we can go the full spectrum here. We can go from that, we can go to a smaller company. Well, then it's really relationship, because usually it's not going to be the scale of it. It's going to be having a strong enough relationship that you get your position in the queue with that particular vendor. Because you're so small, so a bigger vendor has a lot more leverage, right? So it's working it either way depending where you are and the type of project that you're doing. So we want to reduce waste through better planning. Improve site layout to minimize travel distances. Think about movement of materials through the site, like I said. Pull, don't push. Use just-in-time delivery. And if we're pulling, we are, in a sense, using just-in-time delivery, right? Getting it when we need it. And implement a lot of lean logistics practices. And some of those examples are, in cases of large projects, you might want to decouple the delivery to the project. Because I'll talk about that more in the next session. Like I said, there's a lot of overlap between them. But if we are trying to get things delivered to our site exactly, it might be hard to do that reliably, right? And also the limitations of our site and space. And so on larger projects, it may make sense to decouple the site by renting a warehouse where you can stage things, do some prefabrication there, and then deliver it to the site really close to just in time. And that'll make your site much easier to work in. It's that old saying, like, where would you like to paint the room when it's empty? Or would you like to paint the room when it's full of furniture? I know I've done both, and I know I certainly like painting the room empty, 100-fold. It's just so much easier. And so the same goes with our sites. We have to kind of think about that a little bit, especially on larger projects where it'll make the project flow so much better. There's a cost associated with it. There's a cost for sure. But there's also the benefits. So you have to weigh those out and look at those strategically. Centralizing storage locations close to the work areas. I talk a little bit more about that when I talk about 5S'ing, which is basically systems for organizing yourself and your projects. Pre-contract awards, discuss delivery requirements. That's the millwork example, right? Making sure that we're in line with those aspects. We also want to leverage technology to optimize transportation. Again, we can do some really good planning with BIM models, site logistics, making sure that we've got the proper sizing for lay down areas. We might want to phase the site logistics so that in different stages and phases of construction, we have the logistics taken care of really well. And I'll talk a little, again, this one ties over a lot with motion and wasted motion. That's an upcoming topic, which will kind of shock you when we talk about how that affects the income statement. But of course, GPS tracking systems to monitor equipment and material movements and better inventory controls tying to that side of things is very helpful with our delivery practices. So in conclusions, supply chains, they're really complex. Like this article, it gets into political side of things a little bit. Milton Friedman endorsed it completely, and he was an economist from Nobel laureate economist from the 70s, 80s, 90s that was really vocal about capitalism and basically the importance of it in our benefits to society as a whole. So it can get quite into a lot of different areas, but one thing is for sure, when we look at the levels of complexity and people that we have working on our projects, no one person knows it all. So if they don't, we better be using systems and processes that encourage collaborations. We better be working to be as proactive as possible with things, which very often we're not in construction. And then we should be very agile, expect to be surprised, and that's where we need to do quick iterations. And so a lot of this ties into other facets and systems in lean construction, processes such as last planner system, tax systems, that help us to better plan and organize ourselves so that we are taking advantage of the supply chains that we have. Like I said, this pencil here, this pencil, look at all that went into it, right? We should be kind of like in awe of how we are able to do this and buy this for like pennies on the dollar, like I said. And how are we able to build large building projects and come together as groups and make this work? Well, transportation is a key component in that. Managing your supply chains is very important, and being very proactive in that process in identifying long lead items, listing them as a constraint, proactively working with the suppliers, working with the trades to make sure that we have that reliable transportation, getting things pulled to the site, delivered to the site as we need it. So hopefully that gives you some insight into the transportation side. It is really fundamental when we add in the whole supply chain aspect, and from that perspective, it's more than just delivering things. And you're starting to see how these different areas of waste interconnect, but you're also starting to see some commonality of how we can deal with it effectively. So I'm Tom Stephenson, wishing you a wonderful day. And if you enjoyed these videos, please click like, subscribe to the channel. It helps us to grow the community better. Leave a comment, leave examples. That always helps. I appreciate that every time. Okay, so I'm Tom Stephenson, wishing you a wonderful day once again, and we'll see you next time. Bye for now.